Okay, so I've got the midterm, I've got the data, and I can get started. So I guess I'll start up our studio, start a new session, and I'm gonna just start a new R script. If I was you guys though, I would have more than this blank R script loaded. I would well actually in the midterm you're gonna get a sort of a template R script to work off. So you'll download that R script and you'll be working in that R script that you download. But you can have multiple R scripts open at a time. So if you have code that you've worked on before, could you guys sign in please on this sheet? Um, so if you have code that you've worked on before and it's got notes and you've written notes to yourself, this is how you create a z-score by hand, this is how you create a mean by hand or a standard deviation by hand, I would keep that open. So I could just go to my recent files and say, here's my R code. I just want to have that open. So if I forget a certain function or forget how to do something, I can quickly go, to my R code, Command F, and just search for whatever function I need. And then quickly, I'll just find it and I'll remember, that's how you use that. I can copy and paste. Seriously, with R, copying and pasting saves you so much time. So, I think it's the same data, but people did different questions on that same data. Because it doesn't give two download links, does it?
It does.
Data download link. Okay, well, yeah, maybe they are different data. So, yeah, so I was actually downloading it from the study guide, which only gives one link. So I'm not sure which of those versions I have. Maybe just download it from the study guide. This link here. Cool. So yeah, you're going to have the template, but here I'm just going to say, okay, pause midterm practice. Okay, so yeah, let's get started. I mean, the basic structure of it is stuff that you've already done a number of times now. We give you a data set, we ask you to clean the data set, organize the data set, and then run a couple of analyses on the data set, and also give us some descriptive statistics of some variables, and maybe make a couple of graphs. So it's all stuff that you've done, but it's going to be in the high pressure environment of a midterm situation. So you're going to have to take that stuff that you've done at home and just be able to do it on demand. So could you sign in? Thank you very much. Cool. So let's get started. Description of the study. So first it's just going to describe the data that we're going to be working with. It says, Dr. Professor conducts an experiment. Students completed a self-esteem survey and were randomly assigned to watch one of 3 different videos at the beginning of the semester. Dr. Professor measures students' performance with quizzes. So this is dependent variables. So already we've been given a couple of independent variables, self-esteem and condition related to these different videos that these students watched, and our dependent variable, which is going to be students' performance with quiz. And Dr. Professor wants to know whether the videos and self-esteem have any effect on students' quiz grades. So the data file contains information on the following variables. So we've got x1 to x4, which are the self-esteem items. So looking at these items, what do you notice about them? Hi, welcome. Could you sign in?
Yes, of course.
What do you notice about these items straight away from reading them? Yeah.
2 of them should be like reverse scored.
Yes, exactly. Which 2?
X2 and X4.
Cool. And why those 2?
Because while the others measure self-esteem as like a positive thing, so like high self-esteem, the others are more measuring like your lack of self-esteem.
Perfect answer. It's a self-esteem scale. We want to create a self-esteem scale. Therefore, people with more self-esteem should score higher on the scale because we want our scale to be a continuous measure of self-esteem. Question 2, question 4 are kind of measuring lack of self-esteem. So we need to reverse those ones particularly. Cond, this is going to be a categorical variable with 3 levels. ACAD, cat, or tiger. You guys don't have to deal with 3-level variables yet. So we will collapse this into a 2-category variable later, because that's all you've been taught so far, and that's all that's going to be on the exam. And then Q1 and Q2, and these are the quiz scores of the students. So let's start by just loading the data. I know, for example, that my data is in my downloads folder. So I'm just going to say read CSV, in quotation marks, squiggly line / downloads / tab, and then what is the data called? It's called television class data. So then you can just sort of start typing it and it should come up. So that command loads it for me, but that command won't necessarily load it for you. Like, it totally depends on what kind of computer you're using, for one thing, and also where you've stored the data set. It'll probably be easier if you call your data dat. Hi, how's it going? Could you? Just because that'll make your code identical to mine as we're working through. So load the data set. You should see that it's 204 observations of 8 variables. If you don't see that in your environment, let me know. Because it's far better for us to take an extra minute now and have you like on board and keeping up with everything than for you to like not be able to load the data and be sitting there the whole class, like not benefiting from anything. So I'll give you guys a minute to load the data and let me know if you're having problems. Cool. So who doesn't have the data loaded and can't see that it's 204 observations of 8 variables? Great. So let's move on. So one thing I like to do when I load data sets is just check the variable names, which you can do with the command names. And so running that, we see x1, x2, x3, x4, q1, q2, cond age. So exactly what they told us was in the data set. So far we're looking good. So we've got to start cleaning it. So data cleaning 3 points. I'm just going to copy and paste all of this into R. And just sort of clean it up a bit. Okay. So it says complete these 3 steps before answering the questions on the next page. Paste screenshots of your R code and output below each of the 3 steps. You can use any function or method to answer the questions. So there's no need to do anything by hand. And yeah, I don't think you need to do anything by hand on your midterm, but I'm not 100% sure. I just had a quick look at it this morning. Okay. So firstly, we need to report the sample size as well as the mean, standard deviation, and range of sample age. So what's the easiest way just to report the sample size? What's that? You can, can't you? Yeah. And that's, yeah, but how do we do it with code? Because I think we want the code answer. Nrow, exactly, yeah. So nrow dat. I mean, I would give you marks if you just screenshotted that guy, because you're totally right. So nrow dat, done. And I might actually just screenshot that quickly as just showing that I've done that first step. Okay. So now step 2 is, oh no, we're not finished. We're nowhere near finished, are we? Okay. sample size as well as the mean, standard deviation, and range of sample age. Okay, so how do we get the mean of sample age? Question? 238. Make sure you download the data set from the link in the study guide, because it seems like there was two versions of the data from the practice midterm itself, Form A and Form B, which the professor does sometimes so people can't copy off the person next to them. So download, does anybody know if we are working on Form A or Form B?
I think it's Form A just because I accidentally did Form A.
Form A and it's 204?
So.
Right. So I think Form A is the one we want. Did you do Form B? Right.
There's no difference between the data. It's just on some questions, there's like for Form A, they're like standardize the data, and for Form B, they'll standardize the data.
Okay. Did you download both when you did that?
Yeah.
Nice.
Also the keys.
Thorough.
And then
The key is the same. Okay. All right.
so download the one.
Yeah, so the midterm study guide has only one link to the data, and that's the one I'm working from. So, all right. Okay, so how do we get the mean of the age variable? Yeah. Well, actually, I'm not sure I can use describe. Who knows why?
We didn't load the library.
Yeah. So describe is a function in the Psych library, and I haven't loaded that library yet. So I would fail miserably if I tried to use describe. However, library Psych will be the key that unlocks describe. And look, yeah, describe is a really good function because it gives you the mean and the standard deviation in a click, right? So the mean, it also seems pretty good at handling missing values, although I'm not totally sure we have missing values in this variable. Oh, really? So the mean of that age gives us NA because mean doesn't like missing values. So describe's useful in that sense too. So yeah, I guess maybe just use describe. And you can see, so the age variable is down the bottom. I mean, we can be more specific with describe and just say, okay, just describe age. And that might give us a nicer screenshot. So it also gives us, I mean, it gives us the range also. So like I'd be inclined to accept that as an answer if you just did that, but I might want to see you also write out in your midterm, the mean is this, the standard deviation is this, and the range is this, just to show you didn't just like run this command and show you know actually what the output of describe means. All right, cool. So yeah, let's just do that. So I'm gonna say, take this screenshot, I've described that. Cool. So now, I guess I'll just, I mean, it's kind of a waste of time, but I will put the screenshots in the document. Why not? Copy, okay. So I believe you can just drag and drop them. So that's gonna be my first one, N row. And then the second one is up here. Great. And then I might just want to say something like sample size equals 204, mean of age equals, what is it? 21.8. SD of age equals, what is it, 5.26. And then range of age equals, I'm actually more used to ranges being written this way, 19 to 80, rather than just give the value 61. I think in the psych literature that's far more normal. It's much more informative than saying that the range was 61. Because 61 could mean 5 to 66, or it could mean 39 to 100 or something, you know, so give people as much information as you can. Cool. So that'll probably get us full marks for step 1. Step 2, create a new variable, quiz. That is the average of Q1 and Q2. Remove students who had a 0 on this new variable. Waitlist students who never made it into the class. And report the number of students who were removed. Okay, so yeah, we've got Q1 and Q2. We need to make them into this dependent variable called quiz with capital letters. So do we need to reverse either of these? Yeah, but these are the quiz scores. So it's just like a score. Should we reverse any of them or no, right? Because they're both the right direction. High scores mean they did better on the quiz on both. Okay, so how can we combine these into a single score? Like what's that? C-bind, yes. So C-bind and now what? Yeah, so the scores are called Q1 and Q2. Okay, so dot Q1, comma, dot Q2. Okay, so this is good. This is a good start, right? So this is going to take those variables and just sort of bind them together. But we still need to do more than this. We need to, for everybody in the data set, we need to compute their average. So person 1, they did 8, they got 8 and 8, so their average is 8. Person 2, 0, so their average is 0. So how can we compute those means of the rows? Row means, nice. Row means. Okay. Is this code going to work? No, why? What's that? Actually, NAs will be okay. We don't even have NAs, but even if we did have NAs, row means the function would deal with them. But there's a problem with how I've written this. Can anybody see it? Yeah. So row means needs the capital M. Will not work without it, look. Nothing. R is case sensitive. Right. So this code's going to create the means, right? But I'm not quite done. Like, what else should I do? Because I don't actually just want to create them.
You need to assign it to a variable.
Exactly, nice. So what should we call it? Quiz, right. So one thing that the professor does a lot is he'll just create an object called quiz, which is just a vector of the means. I strongly recommend you actually attach it to the data set. So I would say like far better is to do $quiz. It can just prevent a lot of problems. If you create all these different objects that are not attached to each other and sort of, like imagine you're working in Excel, say, right? And every time you compute the means, you create a new Excel spreadsheet that just contains those means. It's pretty easy to see how that would lead to problems, right? Because you could reorder one data set and the other data set doesn't get reordered. You could remove missing cases from one data set and they don't get removed from the other data set, right? So like, it just makes a lot of sense to keep everything together in one data frame. So this is what I strongly recommend to do. Dat money quiz, row means, cbind, dat q1, dat q2. Now with I don't know if this is really even worth telling you guys because we don't have NAs in this data, but NA remove equals true inside the row means function. People almost always would use that. The reason is, like, if I have an 8-item scale and the first participant, say, answered 7 out of those 8 items, but they have 1 missing, if I don't put NA remove equals true in row means, they'll be just NA in my data. So I'm going to basically just ignore the fact that Well, I measured them on this variable 7 times. And row means will think, well, I don't have enough information to compute a mean for this person. So NA remove equals true will allow you to compute a mean from incomplete data, which we almost always do in psychology. But for your midterm, yeah, it probably doesn't matter. But it's good to know that. So including NA RM equals true, let's row means compute means from incomplete data. Okay, so let's run it. And I guess like I just do this reflexively, but anytime I create an object, I automatically highlight that object and run the code, and just like it just feels good to see the object that you just created for some reason. I don't know, it just makes me feel secure and safe to like yeah, just to see that your code worked. Like you were trying to achieve something and you achieved it. So like, I don't know if it's a habit you want to get into necessarily, but the best way to check that what you did worked is just to highlight the object that you were trying to create and run it. And here I can see that, yeah, that quiz exists, and it gives me exactly what I would expect to see, which is a vector of values. So I'm satisfied that it worked. So we've created that quiz. Okay, so now we have to clean it. So how should I remove all the people who score 0 on this variable? How can I do that? Yeah. Well, na.omit is super useful, but it's not going to help us here. Yeah. And like the people that we want to omit are not NAs yet, right? So they're actually, we want to remove the people who are zeros on this variable. So how can we do that? Yeah, yeah. That would work. We might, if we did that, we might accidentally omit cases that we don't want to omit. So, for example, what NA omit will do is it will remove basically any case from your data that has any NAs. So it's possible that somebody just didn't tell us their age, for example. But we could still use their data to look at the relationship between self-esteem and quiz score, right? Or the relationship between what video you watched and quiz score. So we probably don't want to just exclude them just because they're NA on age.
Do you do like indexing, like dat $quiz and then index dat $quiz equals 0?
Hey, good answer. So dat $quiz equals 0. Yeah, you're right. This is like not going to work, but it's super close to code that will work. Equals, exactly. Yeah. So basically, a single equal sign functions as a sign. So R is going to be really confused by this. I don't think it'll actually do anything. So yeah, it says unexpected equals in dat $quiz. Yeah. So it's basically saying, yeah, I don't understand this code. And that's because, yeah, single equal sign is a sign. It's assigning what's on the right to what's on the left. Equals has a completely different meaning. If you use equals, you're basically telling R, give me a true-false response, and make it true whenever this is true, whenever dat quiz is equal to 0, and make it false whenever dat quiz is not equal to 0. So if I just highlight dat money quiz equals 0 and run that, look what I get back. False, true, false, false, true, false, true. So it's what we call a logical operator. And using dat money quiz with that inside the index gives us just the cases of dat quiz that are equal to 0. So now that we do that, what else do we need to add to this code? Assign it to NA. Well done. Yeah. So what this is going to do is it's going to say, for all those cases of dat quiz where dat quiz is equal to 0, make them NA. Perfect answer. You just needed to know that it was double equal sign. So now if we look at dat quiz, and I'm doing what I always do, which is just to like highlight my object that I just worked on and make sure it looks like I want it to look. Now you can see, yeah, there's no zeros here. Everybody who was 0 has been turned into an NA. So, yeah, this is, in my section, we got into a bit of confusion the other day because even though we've made these people NA on uppercase quiz, they're still there for Q1 and Q2, right? So their zeros are still there in Q1 and Q2. So if we run an analysis on Q1 and Q2, we haven't removed these people from those variables yet either. And that gets you into trouble a bit further in this practice midterm because you're asked to do something with Q1 and Q2. So it's kind of it's quite a tricky part of this midterm to like just see if you can think on your feet and think logically about what is this data, what is the data I'm working with, is everything looking the way it should. Okay, so we also have to report the number of students who were removed. How can we do that? I mean, I could have just done it by counting all the zeros, but how can I do it now?
Could you run the same function at the beginning, right, in rows? Or length?
Yeah, good one. You could. It's not going to work because there's no zeros left now.
Oh, okay.
So, yeah.
Can you like not do that step and go straight to the sum and then like the equals 0 and if I did that and it like said 40 but then I tried to do that one and then this one and it said 0.
Yeah, because we took them out. Right. So yeah, you're exactly right. So we could go back here to this step. We could create that quiz again. And I think what you're suggesting is just sum of dat quiz equals 0.
And then comma NA RM.
Comma NARM. Oh, yeah. Yeah, that'll work. That's pretty tricky.
Them out, or
What's that?
did it actually take them out or
It took them out, but I put them back in because I ran this line again. I ran line 25 again. So just after the variable's been created, we can ask for the sum of these trues and falses. Because when you ask for the sum of trues and falses, it gives you the sum of the trues. I think this is a bit tricky though. I think this is like a higher level of R than we need to do. Actually, what I would do is just ask for a summary of that quiz, because summary counts the NAs. Length would also work. We could say dat quiz, and now we have to specify that we just want the NA cases. Do you guys remember how to do that? It's kind of different to how we specify have to be equal to 0 or has to be lower than 0 or something like that. It's actually a special function. Have you guys been shown? I think you mentioned it before. So it's actually is.na. So what you can't do is dat quiz equals NA. Doesn't work. But the exact same thing can be achieved by is.na dat quiz. If I run this, it returns trues and falses whenever cases are NA. And it's very, very useful in data cleaning, actually, is.na. So this will give us 40 as well. So so I'd say this is like, yeah, asking for the length of vector of NA cases. And look, like, if you forget these commands in your midterm, there's actually no reason why you can't just count 40 NAs. Like that actually might be quicker than like, oh my god, what was that function? And you're trying to Google and stuff like that. Like so, yeah, you could just go 1, 2, 3, 4, 5, 6, 7, 8. Like that's actually fine because, as it says in the midterm, we haven't said how you need to get to your answers. You just need to get to the answer, right? So yeah, you'd get full marks. Just take a screenshot of that and just say, I counted them manually and there's 40. All right. So I guess that like we could just take a screenshot of all this and put it in our Google Doc. Step 2. Cool. You probably want the output, don't you? Take it back. Let's do all this again and just print the output. So. Okay, cool. So, here we go. So, no, they're still there in the data set.
So we remove the data by making it.
Yes. Which, if you look at the key, it's what he does. It's not exactly what he does in the key. In the key, he makes their entire row NA.
So he does that step before making the average.
The average? What average?
We binded Q1 and Q2.
Mm-hmm.
So we removed the.
Don't think so. No. What he did in the key was actually better, but there was really no way of knowing that you should do this from the question. I guess you could have. So like what he actually did was this. So can you guys see what this would do? So I'm not calling dat quiz, I'm calling dat, right? I'm still calling the rows where dat quiz is equal to 0. Yeah. So basically it takes those cases where dat quiz is equal to 0 and it just sets all their data to be NA. And that avoids problems further on. But I also not sure you guys have been shown to do that, and I'm not sure that's necessarily something you'd instinctively do just based on this instruction, because all it just kind of says is remove students who had a 0 on this new variable. So removes all of the 0 cases, or it makes them all NA. So yeah, do you guys see how that works? So now because I'm indexing a data frame, I specify rows and columns. So that's why I have this comma inside here now. Leaving the to the right of the comma blank means I'm specifying all the columns. I want to work on all the columns in the data set, and specifying dat quiz equals 0 specifies, okay, on those cases where dat quiz is 0, they're the rows that I want. So it's basically operating on all the data of those rows. I'll show you kind of how this works. So if I delete that guy, and if I was just to run this, you see it gives us back all the columns. But the columns that it gives us, they're all 0 on Q1 and Q2. So running, it's kind of interesting because some of them we actually have data on self-esteem, we have data. So these, I guess, were waitlist students. They turned up to the first lecture maybe, so they got the experimental treatment, but then they dropped out of the course. Some of them didn't even come to the first lecture because they're all NAs. But what this code will now do is make them all this data, it will turn it to NA. And you know what, we can just do that because they told us to remove them. So making them all NA will effectively remove them from the data. And summary.quiz tells us that there's 40 NAs, and this will work the same way as well. Okay, so yeah, it's a bit, yeah, it's kind of involved, but with this stuff here, like with these skills here, you'll be able to get through what's on the midterm. Okay, so now we need to create a scale of the 4 self-esteem items. Graph the histogram for this new variable and describe the shape, then report the mean and standard deviation. Cool, so we have to reverse Q1 and Q2. So how would you do that? No, Q2 and Q4, sorry. No, X1, X2 and X4. I got that. So how do we reverse X2 and X4? Great. Yeah, we need to check like what was the scale. And I think they tell us in our midterm, 1 to 7, right? So, or you could just call describe and look at the values, which is like not totally foolproof because you could have a 1 to 10 scale and nobody ever says 10. So it's good to actually know authoritatively, like, yeah, it's 1 to 7. Okay, so now that we know it's 1 to 7 scale, how would I reverse? What's that? 8 minus XQ. Yeah, cool. So what should I call x2r? Yeah, perfect. Dat x2r assign 8 minus dat x2. This will reverse it. And then it's pretty easy to copy and paste that and say x4r is 8 minus dat x4. Cool. So now what should we do to create our self-esteem average score?
All the variables together.
Cool. And what variables am I C-binding?
X1, X2, X3, X4.
Ah, yeah. Why?
Oh, yeah. So we just
We reversed it. We can't use x2. It's the wrong way around. So it's going to be x2r, x3, x4r. We do actually, yeah. So how does that work?
Just width, and then you type data, comma,
I'm going to type dat, because that's what I call it.
oh, yeah.
Yeah, great. With dat, C-bind these guys. Great. It still is not quite what I need. So what else? What's that? Ooh. Yeah. Self-esteem. There's something wrong with this. What's that? NAs are fine. What's wrong with this code? Row means. Yeah. So this would assign just those 4 columns to dat self-esteem. But we want the row means. So row means, oops. Great. Run it, check our object, looks good. So these are the mean scores. And like, I can see that the first one's 5, right? So just as a sanity check, I can look back at my variables and look at the first case. 4, 5, 6, 5, yeah. So the mean of that guy should be 5. So it looks like it worked. I've got my self-esteem score. So next step, graph the histogram for the variable and describe the shape. So it's just asking for a histogram, nothing fancy. We don't have to change any colors. We don't have to change any labels. So what's the easiest way to make a histogram? Hist of what? Exactly. Hist of dat self-esteem will create our histogram. You can zoom out, take our screenshot. Okay, so how would you describe that shape? What's that? Yeah, it looks pretty normally distributed. I would agree with that. Um, yeah, like, but it's hard though. With only 204 cases, you wouldn't expect a perfect normal curve, even if that variable is normally distributed in the population, right? Because there's always some randomness. The higher your sample size is, the more like perfect a normal curve it'll look like. So, question. Hist, the function is just built to ignore the NAs. Oh, but the histogram's still printed out? So you're probably okay. If you type, what does it say if you type warnings, empty parenthesis? Nothing? Try it again, see if you get the warnings again. Because normally when it says 8 warnings, it says like you can actually check what they are. Oh. Ah, yeah. Huh. Yeah, sometimes in R, the graphing side of R gets a bit hung up on something and it keeps giving you warnings when you're not even trying to make graphs anymore. Generally, as long as what you wanted to do happened, you're kind of okay. Is that a question?
How did you fix the X1 not found?
The what?
There was like an error, X1 not found, and then I got the same thing. That's not
X1
possible.
not found. Oh, yeah. So, object X1 not found. Yeah, so we used width. Because when we just say X1, R doesn't actually think there's an object called X1. It only knows that there's a data set called dat with X1 in it. So we had to use with dat cbind X1. Because when you use with, you're basically telling R, okay, I'm using the dat data set so it can interpret X1 as being a variable of that data set. So yeah, like if I just run cbind on these guys, object X1 not found, right? But if I say, okay, keeping in mind that I'm working with the dat data set, cbind those guys, it works. Oops. Yeah. Questions? Yeah. And to be honest, with 4 variables, that's probably what I would do. Because like here, we've got a function inside a function inside a function, and like, yeah, can start to get a bit. I don't like to see these parentheses stacking up on each other, like at the end. Can get very confusing about which one is which function. Yeah. So yeah, you totally can do that, and to be honest, I would do that. Okay. So we've got our histogram. What else did we need to do with this variable? Describe the shape. And we're just going to say it's pretty normal. Describe the shape, then report the mean and the standard deviation. Okay, cool. So we've seen this. Let's not waste too much time. I'm just going to say describe dat $, self-esteem. And just remind you guys, you need to have Psych library loaded for describe to work. All right. Cool. I'm not going to bother with the screenshots. Like, that's just a waste of your time. So question 1. No, we've already done. No? Have we? Oh, no. We're finally on the question 1. Okay. Report and there's 2 options to do. And I guess I did form A in my class the other day, so let's do form B. Okay. So report the standardized slope, or beta, between quiz 1 and quiz 2. Underneath your output, explain what these relationships say about A, the reliability, B, the validity of Dr. Professor's measure of knowledge about statistics. Okay, so we need to report and graph the standardized slope. So what do we mean by standardized slope here? Well, what's a slope for a start?
Well, is the standardized slope just like the line of best fit, or?
it is the line of best fit, but it's not just the line of best fit. It's a specific line of best fit. But what do we mean when we say the standardized slope?
Is it the thing where you like use the mean to do it, or like
You definitely, means are involved, for sure. So what do we mean when we standardize a variable? What does that mean? Yeah. So, well, yeah, there's different ways of standardizing variables, but for the purposes of this course, generally standardizing a variable means we're going to z-score it. So a standardized slope is actually just a slope on a regression using standardized variables, right? So there's a few ways to do this. I mean, you can like standardize variables within your LM model, within your linear model, but it's probably better to create new variables that represent the z-scored versions of your variables. But here's where we got into trouble because we still had, okay, so now we're operating on quiz 1 and quiz 2, and we still had those 0 students who were 0 on both of them. Hopefully you don't have them. Just check, just have a quick look at DAT Q1. Now we've turned them all into NAs because we ran this line. But if you didn't run that line and you just made them NA in the quiz variable, you would still see zeros in DAT quiz 1. And you would have to do something like DAT Q1 equals 0. Quickly just make them NAs this way. Because we don't want to, I mean, those students didn't take the quizzes. They can't tell us anything about how reliable and how valid the quiz data is because they didn't take the quizzes. So I would, if you still have zeros, I would quickly do this. Yeah, I don't know, like if students did run into that trouble on the midterm, I don't know how it would have affected their grades. But the first time, yeah, in my class the other day, the first time we tried this, we still had all those 0 cases in there. So what's the function to z-score a variable? Yeah. So there's a by hand way, which is just minus the mean divided by the standard deviation, going back to the z-score formula. But there's a way easier way to do it, which is just this scale function. So if you run,